matrices available with us. The other two matrices are, we have already solved the next matrix. So let us see it. So this was our augmented set incidence matrix. After augmented cut set incidence matrix, we have the basic loop incidence matrix, right? So we will see basic loop incidence matrix. Our next matrix, that is the sixth one, is basic loop incidence matrix. Many students are joining now. So you all know how to make this basic loop incidence matrix. So those who have already attended the previous lectures, you can start the solution of the basic loop incidence matrix. You all know how the basic loop incidence matrix is denoted. It is denoted by the alphabet C. So this matrix, which will be denoted by the alphabet C, the basic loop incidence matrix. So basic loop incidence matrix will be denoted by using this particular alphabet. For this, we need to draw the graph once again. So let us draw the graph once again and draw the for this we need to see the previous part that we have written. So this is the actual graph. So this is the graph which was provided to us. So we have to draw this graph once again. So let us draw this graph once again and then draw the matrix which is associated to it. So in the graph we have element 1, element 5 and element 2. So let us check the direction of 2. So direction of 2 is in this way. So element 1, 5 and 2, right? So element 1, 5, 2, and then we have the links, right? So links one by one. When I will close this link number 3, then there will be a loop formation, right? So this is link number 3. Let us check the direction. So the direction is in this way. Now when I close this loop, close this link, there will be a formation of loop. So let us check what is the formation of loop. So the loop in this way is formed. The direction will be in this way. So the name of this loop will be after the branch, that is 1, 2 and 5. So A, B, C allotted to this. So the name of this loop will be D. Okay. And then similarly the next branch, that is branch number 4. So I will close this branch number 4, and after closing this branch number 4 I have to check direction. So this is the direction. So next loop will be loop E. So let me write the loop E. So this will be loop E. The direction of the loop will be in this way. So this is our loop E. Okay. So in this way we have identified the loop and now we have to write the matrix. Okay, so please write the matrix. Okay, so I hope you all are able to write the matrix. So let me write the matrix here. The name of the matrix is C. So let me write C. C is equal to 1, 2, 5, and then the links. So the links are 3 and 4, D and E. Okay. So we have to simply fill this column and that will complete our basic loop incidence matrix. Okay. So let us fill this matrix. So let's go to the D first. So we know that the D is obtained by closing the link 3. So 3 should be positive for D because the direction of D and 3 both are same. Then we have to check the direction of the other element. So when we write D, what are the contents of the D? Let us see. What will be the set of D? So I will write here D is equal to, the set of D will contain 3, then 5, and then 2. Right? So this is the content of the loop D. So we have to check the direction of the loop and the direction of the element. So 3 we have already put the direction. The direction of the 3 and the loop will be same because we are making this loop D by closing the link 3. So this direction and this direction has to be same. Okay. So if this direction and this direction is same, then we have to put 1 here, right? So what about 5 and 2? Let's check. So our loop is moving upward, 5 is also moving upward. So what should be 5? 5 should be positive or negative? Please reply fast. What should be a 5? 5 should be positive or it should be negative? Yes, reply fast. Okay. So 5 should be positive. Very good. Why? Because 5 direction and the loop direction both are same. Okay. So 5 direction and loop direction as both are same, that is positive. Then 2. So check the direction of 2 and the direction of loop. So the direction of 2 and the direction of loop is same. So that's why 2 will be also positive. Is that clear, everyone? Very good. So next is our E. So E, we have set the direction of E according to the direction of the link 4. So link 4 and the loop direction is one and the same. So 4 should be positive, right? So we have to make 4 as positive. So as these loops are formed by closing this particular links, they cannot be negative at any point of time. Okay. Then check the direction. First of all, write the set of E. So let me write the set for E. So E will be equal to, like we have written for D, we are going to write for E also. So E will be equal to 4, 1, 5. So this contents has to be there in this particular column. So 4 already inserted. What about 1? See, 1 is moving upward whereas your loop is going downward. So what should be 1? 1 should be positive or 1 should be negative? Very good. So 1 should be negative. So let me put it here. 1 is as negative. Then my loop is also going upward and the element 5 is also going upward. So what should be 5? Yes, what should be 5? 5 should be positive or negative? Very good. So 5 should be positive. So I will put here 5 in this way. Okay. What about rest of the parts of the matrix? Rest of the part of the matrix will be simply inserted by 0. Okay. So this completes your answer for 6th matrix. So the sixth matrix is basic loop incidence matrix. So the basic loop incidence matrix is completed in this way. Okay, have you all understood? Have you all understood the basic loop incidence matrix? This is one of the simplest matrix. Just you need to follow certain rules. If you will follow that rules, then there will be correct answers that you will get for this particular matrix. Now only one matrix is left over. Let us go with that matrix. So only one matrix, that is the augmented loop or open loop incidence matrix. This is denoted by C and A dot over it. So what you have to do for this matrix, it's very simple. So we have to copy the contents of the previous matrix and insert the name for the branches, that is 1, 2, 5, then 3 and 4. This is the pattern which we had written, and why we had written this in this way, because 1, 2, 5 are branches and 3 and 4 are links. So that's why we have written in this way. Please remember that we cannot write the complete sequence like 1, 2, 3, 4, 5. Why? Because 1, 2, 3 are not branches in this case. Which are the branches? Branches are 1, 2 and 5. So if 1, 2, 5 are branches which is already provided in the numerical, and still you write here 1, 2, 3, then your entire matrix will be wrong. Okay? Is it clear everyone? Please don't make such mistakes. Otherwise the complete problem will be wrong. So here before D and E we have to insert A, B and C, which for the respective branches, and then D and E, which you have already calculated. And then for A, B and C, we know what is the procedure. We have seen it in the previous lecture. So that we will fill. So in the D and E column we have to fill. So D and E column 1, 1, 1, D column, and -1, 0, 1, 0, 1, -1, 0, 1, 0, 1. So this is the content of the previous matrix. So this we have taken from our previous matrix. Okay. So previous matrix was our basic loop incidence matrix. So we have taken this basic loop incidence matrix from the previous one, and we have written this in the augmented loop incidence matrix. Okay. Now for the augmented loop, what we have to do here, you all know. We have put the name A with respect to branch 1. We have put the name B with respect to branch 2. We have put the name C with respect to branch C. So this 3 we have to put 1. Rest all the values will be 0. Okay. So this is the contents of the 7th matrix, that is the augmented loop incidence matrix. So this completes our entire 7 matrices of the this particular problem which was provided to us, and we have very easily completed all the contents one by one, so so that all the 6 matrices are available with us. Is it clear everyone? If there is any difficulty, please ask, as we have to start with a new topic today, that will be the verification of the identities, some identities which are used in this particular situation. So if there is any problem with anyone, please let me know so that we can start with the next one. Yes, any problems with till now? Okay, then if there is no problem, let us start with the new problem, and with this problem we will be verifying the identities. So please write the problem. So this is our third problem that we are taking in this particular unit. So I will draw the graph. So graph of network which is given to us, which is in this way. So I am drawing the graph of this power system network. This is element 1. This is element 2. Everything is supplied to us, right? So we need not worry at all. We just have to apply our concept and solve the problem. Okay? So there is no problem. We will solve it by using our concepts which we have solved till now. So this is your element number 3 as provided in the power system network. This is element number 4 and this is element number 5. So in this way a graph is provided to us, and what they have asked, let us see what is the question. Prove the following identities. Okay, so let's see what is the first identity. The first identity is AB K transpose is equal to U. Don't worry at all, just write the question. We will prove one by one this identity and we will see what all these matrices are all about. BL is equal to AL K transpose. Then third is CB is equal to minus BL transpose. So these are the three identities which are to be proved by us in this particular problem. Okay. So there is no problem at all. We will solve this problem according to the part which we have, according to all our basics which we have solved till now. Okay. So are you all ready to solve the problem? So are you all ready to solve the problem? Okay, so this is something new that we are looking in today's lecture, right? So let us start the solution. So immediately after getting the graph, what we actually do is we have to draw a tree and co-tree. So we know a tree and co-tree is comprising of the branches and the links. Ultimately, what we write here is, we write here our formula, that is ENBL, because here in this problem only the graph is provided to us, right? Whereas they have not said previous problem, in the problem itself the dark and the dotted lines were given. Dark and the, what does the dark and the dotted lines indicate? The dark lines indicate the branches and the dotted line indicates the link. And when we have the dark and the dotted lines, that is the branches and the links, we say that the tree formation is there. Whenever we have only branches, we say that tree is there. And when we have the branches as well as the links, we say that co-tree is present. So in other words, we say that tree and co-tree of that particular graph is provided to us. Whereas in this particular problem, the tree and co-tree is not provided to us. Okay. So we have to identify the tree and co-tree for our choice, and then we LK transpose and CB is equal to minus BL transpose. So these three identities we have to prove one by one. Now, you know, if AB is there, that means it has something to do with A, that is, and what is A? A is our bus incidence matrix. So you all know how to make the bus incidence matrix, right? Then here what you can see is K transpose is written. That means first of all you need to find K matrix. What is K matrix? K matrix is branch path incidence matrix. So first you need to calculate, or first you need to draw the branch path incidence matrix. Once you have the branch path incidence matrix with you, then you can make the transpose of that matrix so that you will get the K transpose. Then when you multiply these two, you have to prove that the matrix which will come is a unity matrix. That is, the diagonal element should be 1, 1, 1, 1, right? So first of all you need to find matrix A, then you need to find matrix K, and after that only your first identity will be proved, right? So what is the requirement is, you can see here the nomenclature A is written, K is written, B is written, C is written. That means, in short, you have to make all the matrices which you have learned till now. Is the concept clear to everyone? In order to prove all these three identities, if you want to prove all these three identities, the basic concept that you have solved till now, that is to calculate all the 7 matrices, that will be required. If you can write properly all the 7 matrices, then one by one you can start proving these identities. Otherwise, you cannot prove any of the identities. So to prove the identities, what is the requirement? The requirement is to find all the matrices one by one. Okay. So for that, we require the graph of this particular matrix. All right. Is it clear? So shall we start? Shall we start with our steps as we had did in the previous two numericals, calculation of all the 7 matrices. So in this problem, after solution of all the 7 matrices, you have to prove this identity. So a step ahead is to be done by all of you in this particular problem, right? So let us write all these points first. So E stands for elements. What are the total number of elements here in this graph? Can anyone reply? What are the total number of elements in this graph? See, graph is already provided to you. So you have to identify the total number of elements. Very good. So the total number of elements which is given in this graph is 5, right? Then we have to identify the nodes. So how many number of nodes are there in this problem? In the graph, how many nodes are present? Very good. So there are 4 number of nodes present. Now for B, that is branch, we have the formula B is equal to n minus 1. So n minus 1 means 4 minus 1 and 4 minus 1 means 3. That means in this particular graph, we have to identify 3 elements as branches, and if we identify 3 elements as branches, then naturally we will be having 2 elements which will be links. So as in the problem only graph is given, so you are free to choose any of the element as branch and the rest of the element as link. But while doing so, the rule that we have followed, that should get balanced. Okay, what was the rule to identify the branches? The rule for identifying the branches was all nodes should be present, first rule, and second rule, there should be no closed path, right? So these were the 2 rules that we had already started with, and we have written these 2 rules. So with the help of these 2 rules, what we have to do is we have to identify the elements as branches and links. Now for simplicity, for to make the problem simple, what I have suggested you the thumb rule. The thumb rule that I have suggested was, first check whether first elements can be taken as branches or not, and then select the rest of the elements as links. If this rule, this concept fits into our rule, then we can go ahead with this thumb rule, and if this thumb rule doesn't fits with our rule, then we have to drop this. We were talking about the branches and the links. So as in this problem only the graph is provided to us, they have not asked us to make certain elements as branch and the other as link. So here we are free to choose the branches and link by our own choice. Okay, so if we are free to take the branches and link by our own choice, then we have to take the first thumb rule that we have decided. The first thumb rule was, first check whether the first elements can be taken as branches or not. If first 3 elements can be taken as branches, then go with that rule. Otherwise you have to apply the rule, that is first rule was to when you choose the branches, you have to check that whether all the nodes are considered or not, the first rule. The second rule, there should be no closed path. So let us try here. So here the first 3 elements are 1, 2 and 3. So just let us check whether if we can take the 1, 2, 3 as branches or not. So 1 and 2 is okay, but when we take the third element as a branch, you can see here a closed path is forming.
So if we take this third element as branch, then a closed path is forming. So that's why 1, 2 and 3, this combination cannot be taken as branches. Is it clear everyone what the thumb rule says and what the rule that we have to apply? So as per our thumb rule, we are trying to set 1, 2 and 3 as branches. But while doing so, we have to also check whether the rule is getting satisfied or not. So the first rule is that all the nodes should be present. So see, if you take 1, 2 and 3 as branches, then this node number 2 is getting isolated. That means this node number 2 is not coming into picture, right? So node number 0 is coming, node number 1 is coming, and node number 3 is coming. What about this node number 2? Node number 2 is not coming in picture if you take 1, 2 and 3 as branches. So 1, 2 and 3 cannot be taken as branches. Is it clear everyone about the thumb rule? Please reply fast, because we have to follow the thumb rule as well. So if the thumb rule is not, if the rules are not getting satisfied, if the conditions for taking the branches and links are not getting satisfied, we cannot take that particular elements as branches. Okay, so then if we cannot take 1, 2 and 3 as branches, let us try with the another combination. Let us try with the combination of 1, 2 and 4. Okay, so let us try with that. So if you take 1, 2 and 4, let's see whether the conditions are getting satisfied or not. So the first condition is that all the nodes should be present. So let's see. So 0 is present, 1 is present, 3 is present, and 2 is also present, right? So first rule is getting satisfied. What about the second rule? What about the second condition? The second condition is that there should be no closed path. So yes, if you take 1, 2 and 4, there is no closed path also. So that's why we can take the branches as 1, 2 and 4. Is it clear everyone why I am taking 1, 2 and 4 as branches? Because 1, 2 and 3 cannot be taken as branches because the rules are not getting satisfied. So that's why we are going to take 1, 2 and 4 as branches. So if you take 1, 2 and 4 as branches, what is the left? What are the balance elements? The balance elements will be links. So the balance elements are 3 and 5. So let us draw the tree then. So this was the graph which was provided to us. Now let us draw the tree and co-tree. So tree, okay. So this is my node number 0. This is node number 1. This is node number 2. And this is node number 3. So see, I have taken 1, 2 and 4. Let us check the direction of the 4 as it is provided in the problem. Don't change the directions as per your choice, otherwise you will end up with a wrong solution. Okay. So these are our branches. So if we draw only branches, this will be a tree, and if we want to draw a co-tree, we will have to draw the links also. So this is our link. Let us check the direction as provided in the problem. So the direction of this is in this way, 5, and the other one is this, so 3. Element node incidence matrix for you. So for element node incidence matrix, we have to write the sequence properly. So what is the sequence? The sequence is first branches and then links. So what are our branches in this problem? 1, 2 and 4, and the links are 3 and 5. So we have to write in this fashion only. If you will change the pattern, then you will end up with a wrong result. So don't do like that, otherwise the entire solution will be wrong. So one by one we have to write all the nodes here. So 0, 1, 2 and 3. Okay. So then we have to start. See, A dot is not asked to us in the problem. What they have asked is to solve this particular identity.
See, check the first identity. So if you will check the first identity, they have asked you AB. So in order to find the AB, you have to make the matrix A. But for making the matrix A, you have to first cross check the matrix A dot, right? So we that's why we are making this A dot, right? After A dot is prepared, it's very easy for us to draw the A, right? So that's why we are going to first calculate the matrix A dot and then respectively A. So let us first fill the column of 0. So for filling the column of 0, what we have to do is we have to go to this node number 0. So we can see here in this node number 0, 1 and 2 is incidence. So in this node number 0, 1 and 2 is incidence, and we know that outgoing is positive and incoming is negative. So that's why what we can write here is 1 and 2 both as positive. Why 1 and 2 both as positive? 1 and 2 both are positive because both 1 and 2 is outgoing. Now I'm making this matrix quickly because I have already explained how to make this matrix. So I'll not be spending much of time to explain how to write the entries of this matrix. Then for 1, I have to go to node number 1. In node number 1, we can see there are 3 elements which are incidents: element 1, element 4 and element 3. Element 1 is incoming and 3 and 4 is outgoing. So let us make 3 and 4 positive first and then element 1 negative, because 1 is incoming. Then for filling the column 2, we have to go to the node number 2. In node number 2, we can see there are 2 elements 4 and 5 and both are incoming. So as both are incoming 4 and 5, so we will put here 4 and 5 as minus. And last is filling the column number 3. So column number 3, we have to go to the node number 3. Node number 3, we can see there are 3 elements which are incidents, that is 2, 5 and 3. Out of this, only 5 is outgoing, 2 and 3 is incoming. So let us make 5 positive first and then 2 and 3 incoming, that's why 2 and 3 negative. Rest all the entries will be replaced with 0. Okay, so this is your matrix A dot. Let us cross check this matrix whether we have written the entries correctly or not. So what is the mechanism to cross check? The mechanism is very simple. Just check the summation of all the rows, because we know the rule of KCL. What is the rule of KCL? Whenever we take a certain node, then the summation of all the incoming currents and the outgoing current should be equal to 0. So the same concept we have applied here of KCL. So the summation of the entire row should be 0. So let us check: 1 minus 1 0, 1 minus 1 0, 1 minus 1 0, 1 minus 1 0, minus 1 1 0. That means the matrix which we have written here, A dot, is correct in every sense. So once we are done with A, we can very well A dot, we can very well write A. What is A? A is nothing but the bus incidence matrix, where we have to just eliminate the reference node, because we are considering the physical buses in this particular matrix, and for considering the physical buses, we have to simply remove the reference node from the A dot matrix, and the matrix which we will obtain will be called as the matrix A. So let us write the matrix A here. Simply we have to go to the A dot matrix and start filling all the entries from the A dot matrix. So column 1 is minus 1, 0, 1, 1, 0. Then column 2 is 0, 0, minus 1, 0, minus 1. Then column 3 is 0, minus 1, 0, minus 1, 1. So this is your matrix A. Now in your identity, you can see they have asked you A suffix B, that is AB. So now we will see what is this concept all about, what exactly this AB is. So for this, what we will do here, we will partition this matrix A into branches and links. So you all know which is the branch part. Branch part is up till here, and the lower portion is of link, right? So this portion of the matrix will be called as A suffix D, and this portion of the matrix will be A suffix L. Is that clear, everyone? So if I write A, B, then A, B, how I can write? Let us see how this A, B can be written. So this A, B can be written in the form of matrix in this way: -1, 0, 0, then 0, 0, -1, and then 1, -1, 0. Is that clear, everyone? What is this A, B? Please reply quickly. Is that clear how we have written this A, B? Similarly, we have to write AL. So AL will be the matrix in this way: 0, -1, 1. So here I have explained you how to write A, B and AL. It's very simple. For writing A, B and AL, what you have to do is you have to partition the matrix. So what is the partitioning? Partitioning is, you know that you have written first branches and then links. So this is the reason why we have written first branches and then links, because we need to partition the matrix in two parts, right? So the first part will be A, B part, and the second part will be A, L part. Okay, B stands for branch and L stands for link. So you see that for proving the first identity you required AB. So is AB available with us right now? Is AB available with us right now? In order to prove the first identity, what is the requirement? The requirement in LHS is AB multiplied by K transpose, out of which AB we have obtained. Alright, everyone? AB we have obtained. We are only left over with K transpose, right? So if we want to write the K transpose matrix, what do we require? We require K matrix first, right? So K matrix is branch path incidence matrix. You all know how to draw the branch path incidence matrix, right? So you all know how to draw this branch path incidence matrix. So in order to draw this branch path incidence matrix, we have to draw the graph once again. When we draw the graph, we have to draw only the branches, right? So we have to draw.
Okay, so is it clear, everyone? For proving the first identity, we require AB and K transpose. So AB, and out of this AB and K transpose, we have already obtained AB. Now what is our job? Our job is to obtain the K transpose matrix. You all know how to obtain the K transpose K matrix. So in order to find the K matrix, we have to draw the branch path incidence matrix. So you all know how branch path incidence matrix is made. So you all know how to draw the how to make the K matrix, right? So for making the K matrix, I will not exactly explain all the complete procedure. What I will do here is I will just write the K matrix. So you can check it in your book, so that we can solve the. So I'm not going to write the complete graph over here. So I will just write the K matrix here. Then we can prove the identity, right? So K will be equal to 1, 2, 4. And here the paths, I will have path number 1 respective to A, sorry, 1, then path number 2, and then path number 3. So I'm not drawing the graph once again. So you have to do it in your copy and write the matrix accordingly. So I'm going to write the entries of this matrix as -1, then -1, and then -1, 0, -1. So this will be the matrix K. So from here, what you can write, the matrix name is, from here the name of matrix you can write here as K is equal to, in this way, -1, 0, -1, 0, -1, 0, 0, 0, -1. So here you have to just remember one thing. While drawing this matrix, you have to follow the paths which is related to the to your respective branches, right? So respective branches, you all know how to write the paths. So if you will write here, if I will make, if I make the changes here, so you can see here the path will be in this way: the first path, the second path, and the third path, right? So I'm not drawing here again the graph. You can make it in your copy, the graph, and you can solve it accordingly. So I will just explain here how the things will move and how you have to prove the identities one by one. Okay, so now K is available with you. So if you have K available with you, what will be K transpose? Simply make the transpose of this matrix. You all know how to make the transpose of the matrix. In order to transpose this matrix, you have to make the rows into column. So if the rows are converted into column, what will be the situation? So -1, 0, -1, then 0, -1, 0, and 0, 0, -1. So this will be K transpose. So now you have K AB with you. You have you have K transpose with you. So will you be able to solve the first identity now? So what is the first identity that they have asked you to prove? The first identity that is being asked to prove is, first identity is AB into K transpose is equal to U. So first start with the LHS. So if you will start with the LHS, you have AB multiplied by K transpose. So just take the matrix AB. What is AB? -1, 0, 0, 0, 0, -1, 1, -1, 0. So we will write here in this way: AB. So AB is -1, 0, 0, then 0, 0, -1, and then last row 1, -1, 0. Then I have K transpose available with me. So what is K transpose? -1, 0, -1, then 0, -1, 0, and last row is 0, 0, -1. So for this you need to learn the matrix multiplication technique. So you all know how the matrix is multiplied. So when you will solve this, you will get the result in this way: 1, 0, 0, 0, 1, 0, and 0, 0, 1. So this is nothing but the unity matrix, and in this way your first identity will get proved. So this is nothing but RHS, hence LHS is equal to RHS. So this will make your proof. So hence prove first identity. And this is your answer of first bit. Alright, is it clear everyone how we have proved the first identity? So this is the something new concept which we have learned today. So I have explained you the procedure how to solve the identity one by one. So similarly, if they have asked us to solve the another identities, let us check what is the second identity, and then so second identity is BL is equal to AL K transpose, right? So out of which you already have K transpose available with you. You already have AL available with you. What is AL? AL is this matrix which we have already calculated while solving the A matrix. Then what is left? What is left to you? The left is BL. So what will be BL? For BL, you need to first find out the basic cut set incidence matrix. Then when you get the basic cut set incidence matrix, again you have to make a partition of the matrix. The upper part will be for branches, that is B suffix B, and the lower part will be B suffix L, that is BL. So you will get BL. Then it will be easy for you to prove this identity: BL is equal to AL multiplied by K transpose. So will it be done? I am giving this as a homework.
So will you all solve this particular identity, that is the second one, BL is equal to AL multiplied by K transpose. So only you have to find out BL, that's it. Okay. And the last is CB is equal to minus BL transpose. So BL already you will get from the second bit. You have to simply multiply the BL matrix with minus sign and make the transpose of that matrix. And you have to find CB. What is CB? For CB, first you have to find the basic loop incidence matrix, right? So for CB, first you have to find basic loop incidence matrix, partition it. The upper portion will be CB, lower portion will be CL, because upper portion will be always for branches and lower portion will be always for the links. So in that way you will get CB. So then prove the third identity, that is CB is equal to minus BL transpose. So this two parts is homework for you. Tomorrow, in tomorrow's class, we will cross check it whether these two identities are getting proved or not by using this particular problem. Alright, so is there any difficulty to anyone related to today's lecture? If there is any difficulty, please let me know.